So for an introduction, there have been traditional approaches to fluid dynamics like the numerical methods, wherein you simulate the movement of per particle using differential equations like the Navier Stokes equation. So what's the Navier Stokes equation? It describes the motion of fluid substances like gases and liquids, and you describe it as a function of acceleration in terms of the change in pressure of the liquid and other viscous forces that are interacting. So the Navier Stokes equations are derived from conservation principles. So conservation of mass, energy, momentum, and angular momentum. So next week I'll study the derivation of the Navier Stokes equation. So what's the other approach, emerging approach in studying the fluid dynamics? So another approach is using cellular automata. So another term, so an automaton is any computer with a finite number of states, and its behavior depends on a set of rules. Now a cellular automaton consists of a lattice, so like this rectangular array, and then there's a discrete number of clock ticks, so for state 1 and state 2. Okay. Then so a few applications. So CA has been used to simulate physical processes like diffusion, wave propagation, and fluid flow, like this diagram. So it has a potential for complex engineering designs, pero very compared to sa traditional design like control systems, hindi pa mature yung C. So
yeah, kasi ano yung physical basis, parang ano lang siya, artificial set of rules.
So nagkakaroon ng parang experiment, parang compare yung CA model with existing differential equations and describe how the accurate is. So Wolfram studied different applications. So it has a potential for more accurate simulations according to my literature. So what are the examples of models? So we all know the classical models like the game of life. So the game of life only analyzes the number of neighbors. So it has more than 4 neighbors, a cell dies. So
manggugulo ako in terms of style. Go back to the previous slide. Okay. That picture, where did you get it from?
Basta parang it's a diffusion automata.
No. What was your reference to that picture?
Google Images.
Okay, well then you should always put the reference underneath. If the URL is complex and may mga PHP pa siya, etc., you can at least just put a key URL.
Go on. So this is the old classical model. So it's the classical model of you only analyze the rules based on the number of neighbors. So the game of life, and then there's the quasi-particle model, and which is used to model fluid dynamics. So you use the concept of lattice gases.
Okay.
So what are the properties of the lattice gas automata? So each cell is also treated as a particle, but instead of analyzing its movement in terms of a differential equation, we analyze a larger, a macro description of the cell. So we analyze the regions and not per cell. So we analyze its momentum densities through averaging techniques. And then, so if you analyze the region, you analyze large numbers of diffusing particles. So instead of pieces of matter, you analyze it as a piece of space.
Yeah.
Okay. So here's lattice gas automata. So as you can see, instead of traditional neighbor rule, so each cell also has a vector component. And then, so there are two models, so rectangular grids and hexagonal grids. Now, rectangular grids are used in the HPP lattice gas model, so highly permuted Z. So the lattice gas model was able to simulate wave propagation in circular wave propagation. So I can't find the wave propagation limits.
Okay.
So there are a few rules in HPP lattice gas automata. So first is the collision rule. So the momentum of the particle will not change unless it's a silent collision, where in the collision between two 90 degrees. So next is simply the propagation rule in which it moves to the next table. This will just simply move. So in HVP lattice gas automata, you have an alternating series of collision and propagation rules applied, and then by the time you see when you introduce a new particle in a 40% density solution, so you'll see that it will diffuse after a few iterations. Next is the FHP lattice gas. So I will let to read this. So, but this is the model that accurately describes the Navier Stokes solution. So instead of using rectangular grid, it uses the earlier hexagonal grid. So this one, okay, hexagonal grid. So these are okay. These are the rectangular grids.
Okay. You have the electronic file for
I have a full.
Huh?
I have a photocopy.
Mami photocopy ka? Okay.
Photocopy.
2 dimensions.
Computations. So I'm also starting playing with some automata stuff.
Yeah. Is 3 dimensions too much? Should we just limit to 2 dimensions?
Hindi ko sure yung mod. Wala pa akong nababasa ng literature on 3D models. Pero parang yun yung tinatry namin during the local.
Diba?
We'll try to do. After familiarizing myself with 2,
Of course.
try to do.
Pahingi ng sino nagbigay ng reference na yan? Si Rafi. Akit ulit. Na yung second to last slide. Ano yung significance ng black dot?
Ito nag-simulate siya ng fluid. So may first may turbulent.
Pero cellular automaton pa rin yun? Hindi na.
Cellular
So yung figure na yan sa reference 3?
nag-search na ako sa Google yung
Tingnan, balik ka pa sa previous one. Okay, but then go to the last slide. Okay, yung frisch. Nasaan yung frisch? You had a reference with frisch.
Fresh.
Tipo mo.
Pero nandito din sa yung fresh I found it from this introductory. Okay, may initial article siya, pero babasahin ko pa. Kasi may citations din yung article. So hindi ko nababasa yung yung key.
No, that's all right.
Secondary source.
Do you mind if we go to Paul and just lend it to him for about a day? Hindi ko photocopy niya. Gusto ko kumuha ng photocopy. For reference 3 siya ba yung part ng lab na yung where you had fish. I think you'll be able to copy it for half a day na you'll get it back.
Wala pa akong copy. Original.
Wala. Naki-Rocky lang.
Actually, nakuha ko.
Nakita mo yung citation niya?
Nakita ko yung citation.
Okay. So we need to get the
Original
paper. So what hard copy?
I have this one and another one. Yung introduction to discrete physics.
Sige nga. Siguro yung ganito, hindi mo naman siguro kailangan i-video dahil talaga yung
Sir, edit naman.
Unforgiving ka talaga.
Content.
Hindi kasi siya wala namang, hindi siya packaged. Okay lang siguro.
So yung chapter on introductory discrete physics, nandito yung, dun lang yung mention yun, pero wala pang depth on chair mo for FHP. So, introduction.
that's all right. So I think you've been reading this.
Actually, I just finished it.
Okay. So if I can get a copy of this, just go to Paul. What else do you have?
Hindi ko pa nababasa pero
That's all right.
cellular parang i-build siya ng argument how to use CA for LGA for resistance.
Oh, cool. Okay. So,
Hindi ko siya ginagawa.
sige, go to Paul and ask him to make 2 copies. Okay, and one set for me, one set for me. Okay. Thank you. Very good.